So using ID probe settings with 20 kilohertz bridge, this is the okay, so what we're seeing here is that's this drilled hole, two drilled hole, 80%, 60, 40, 20, and another 20 groove, 20 set of holes, and going up back to the end here, and then this is support plate signal. Okay, now one of the big applications for dual frequency is to remove support plates because they cause quite an annoying signal. Here I've positioned it beside the drilled hole, and you'll see that that kind of obscures the through hole. So if we could clear that up, that would be a great advantage. So how to do that? Well, here we have channel 1 set to 20 kilohertz, and I've now set channel 2 to 30 kilohertz, so 20 kilohertz, 30 kilohertz. If I now go down here and display the channel, I can have two traces. This is the two support plate signals. I'll get a slightly diminished signal and phase shifted at the higher frequency of the 30 kilohertz than the 20 kilohertz. But I've set the signals so that the drilled hole of both the two frequencies is identical. And if I now go down the tube, you'll see as I go along that the phase gradually separates, that the higher frequency moves faster than the right, so it ends up on the right. Quite a subtle change, but that's quite a useful change as it happens. To mix, we have on this instrument some functions called mixers. The easiest way to demonstrate what's going on is to go to the mixer channel, go down, display the channel before the mix. So what we've basically done here is to go back to the main screen. Maybe I won't, just for reasons of clarity, go down here. So I'm not showing the actual original signal on channel 2. But what we've done is we've put that into a phase and gain shift block, and I've made, let me go and move the probe to the end of the tube, and I've made the responses from the 20 kilohertz channel look as close to the 30 kilohertz channel as possible by manipulating the phase and gain on the 30 kilohertz channel only. So now we've got two comparable signals there, and then mixing basically is subtraction of these two signals. The quick way of showing that is not that quick, is now if I go down, switch off the display of the mix before subtraction, go down the bottom, and now switch on the mix channel. What I've now got is the yellow signal is the residual signal from the mix, and the green signal is the original 20 kilohertz signal. So how does that now look versus the holes? And if I now go along here, so that's residual, this is a drilled hole, so see the drilled hole still coming up. In fact, the signal is slightly larger. We're getting phase shift as before. And now if I go and put the signal part thing, we can see, again, disable the green channel to stop it being confusing. We'll display that. Now that's the hole, and that's the support plate. I think you'll agree that now you can quite clearly see the drilled hole beside the support plate.